Okay, so my presentation is built on the previous one, and in this presentation, I will focus on the GSIM notion of concept, category, node, and node set, and explain how it can be applied in the context of a statistical classification. And to illustrate the different slides and use cases, I have used the NACE classification as the main example. So the goal is to show how GSIM Concept Group support both the design and the interpretation of statistical classification. At the abstract level in GSIM, a concept, for instance, economic activities, so this is in the central green box, is defined as a unit of SO differentiated by characteristic. So a concept system is a set of concepts which are structured by the relation between those concepts. So we have the concept of economic activities or countries used as a conceptual variable. And we have a group of concept system applied to a subject field. So in my use case, this is tourism, based on the field of spatial knowledge. And so then you can see that we have a subtype of concept called a category. So the category is a type of concept whose role is to extensionally define and measure a characteristic. So we have the concept of economic activities in the case of the NACE classification, or the concept of sex with the male and female node inside the concept. So we have three ways in which a category can be used. So it can be used as a node, and the node can be a category in a node set, so a category set, or a code in a node set called a code list, or a classification item in a node set called a statistical classification. So yes, this is a screenshot from the GSIM user manual. And the node is a combination of the category and related attributes for the purpose of defining the situation in which the category is being used. So the node is a conceptual variable. So the node has three subtypes, as I have mentioned in the previous slide: a category item that contain the meaning of a category without a representation, so without a code. So for instance, we have male in the sex list, or energy. Or we may have a code item that contain the meaning of a category with a code representation, with M for male, A0112 for growing of rice in the SDMX activities code list. Or we have the classification item that combine a category at a certain level with one representation. So for instance, 0112 corresponds to growing of rice in NACE, and this item belongs to the NACE class. So the node set is a kind of a concept system, what Dan call a conceptual domain. And so we have for the category, a category set that contain the category via category items, or a code list that contain the code via the code items. So the code list for the code list of activities that include the code A0112, or a statistical classification similar to a code list, but with classification items that combine the meaning of the category with a code representation. And the statistical classification is organized hierarchically and is a set of mutually exclusive and jointly exhaustive category, sharing the same characteristic. So mutually exclusive category means that each element in the classification each element must be classified in one only category of the classification. And jointly exhaustive means there is no gaps in the coverage. So this slide describes the GSIM statistical classification model and its related class. So this is a view of the node set portion of GSIM. So there is a specific documentation about the GSIM statistical classification model. So in the center, we have the statistical classification. The statistical classification is a set of categories with their meaning combined with code representation, as I said before. And it may be assigned to one or more variable used in the production and dissemination of statistics. So the classification contains a classification item at the bottom of the screenshot. And the statistical classification are grouped into a classification family. For instance, the NACE cover economic activities. So all the NACE version belongs, the NACE, the CPA, or the ISIC belongs to the same classification family. And statistical classification are grouped into a classification series. This is ensemble of one or more classification based on the same concept related to each other as version of updates. So we have the NACE revision 2.1 and the NACE revision 2. And then the classification items combine the meaning from the category with the code and additional metadata such as explanatory note, classification index. And the classification item, they are aggregated into level. So yes, they are grouped into level. The NACE is grouped into the section, division, group, and classes. And on the left side of the screenshot, we have the correspondence table. A correspondence table compare statistical classification, and the correspondence table contains a set of mapping, a set of map, and each map map source and target classification items. And on the right side of the screenshot, we have the classification index. So the classification index group the classification index entries. And the classification index entries consist in a short text description describing, for example, economic activities or occupation, to which a classification item applies and refer to one item of the classification. So the characteristic of mutually exclusive and jointly exhaustive is also relevant. So the slide described the implementation of the GSIM concept into XKOS. So what is XKOS? XKOS is a ontology, a data model based on another data model called SKOS. So SKOS is the Simple Knowledge Organization System. It's a common data model for describing a code list, taxonomy, subject heading system, theory. And XKOS is an extension dedicated for the representation of a statistical classification. So in green, we have the scheme. So what Dan called the conceptual domain. So we have as a scheme, a concept scheme, we have the statistical classification, but also the classification family, the classification series, and the index, because each scheme contain a concept. So what we called a concept in SKOS is in fact the classification item. And the concept, they are represented in blue. In gray, we have the aggregate, so the collection or the subclass classification level. So for the NACE, we have the, for instance, the NACE classes. And then we have the, in yellow, the XKOS correspondence, which is a data set that contain a mapping concept association. And so with the arrow, you can see the different properties linking the classes. So for instance, the scheme belongs to the SKOS concept scheme and is linked by the SKOS in scheme property. And we have also, yes, an additional class called the XKOS explanatory note that enable to describe contextual note with versioning, for instance. So now in the next slide, I will go into detail in the different XKOS classes. So the first classes is the classification families. It is a group of related classifications sharing a common concept or domain. So in Eurostat, we have defined we are linking the statistical classification to the Eurovoc thesaurus. So for the NACE, you can see in the right part of the screen, we have covers. So the NACE is covered by 4 keywords from Eurovoc. And yes, we would like to use the CSA, the classification of statistical activities. I think it will be the recommended reference framework, but at this stage, however, it is not yet provided in RDF format. So the family enabled to group the classification covering the common concept, such as the ISIC, the NACE, or the NAIX. Then we have the classification series. The classification series is a group of one or more statistical classification based on the same concept and related to each other as version of update. So we have, as example, the NACE revision 2 and the NACE revision 2.1 that belongs to the same series. And we have defined one dataset called European Statistical Classification Series, where we have represented describe each classification. So you can see that we have on the right entry for the NACE with a description with metadata about the NACE, and each classification is associated to the series by the XKOS belongs to a semantic relation. But there is also a second option for linking to scheme, to classification. So we can say that the new version of the classification follows the previous version of the classification. So now we have the class for the statistical classification, the concept scheme. So statistical classification is a systematical arrangement of category. So you can see on the right hierarchy, the hierarchical presentation of the NACE based on a mutual exclusive and exhaustive category representing as classification item. So the classification item is a SKOS concept. It is a type of node that combines the category, so growing of tobacco at a certain level, the NACE class, and a representation, the code, 01.15. And the hierarchy inside the concept scheme is defined by the broader and the SKOS narrower and a subproperty in XKOS specialized and generalized. So this is a link between the concept inside a concept scheme. Then the classification item, they are also supported by additional information. We have the explanatory note, and that's one of the reasons why we an extension of XKOS was really needed, required, because in SKOS we have the scoop node, so that's a generic node. But in for statistical classification, we need to define inclusion node, exclusion node, additional content node, for instance. So this is only possible with XKOS. And we have also the index entries linked to the classification item and the mapping. So we have a mapping between two versions of the names, so from belonging to the same series. But we have also mapping between classifications covering the same domain, such as NACE and ISIC, that belongs to the same classification family. And on the right side, you can view a screen from Shovok. So Shovok is the web-based platform we are using for disseminating the ESS classification, and it enabled to browse and explore multilingual vocabularies and classification, and to search, navigate, and it enabled to customize the view. So we are now customizing the view of the NACE classification, and you can see that here we have replaced the XKOS and the SKOS properties by meaningful terms. Then we have the classification level. The classification level in GSIM is a set of classification items or nodes. They are all located at the same distance from the root of the hierarchy. So the first level corresponds to the NACE, to the NACE section. Sorry, that's a mistake. So represented by a letter, and the depth is 1. Then we have the division, the group, and the classes. And in the right side of the screen, you can see a description of the NACE level 1, the section, and the classification items as member of the level. So we use the SKOS member property for linking classification level to the concept, the items, or a SKOS level for listing inside the concept scheme the levels of the classification. So this is almost the last slide of the presentation. So up to now, we have mainly looked at the relation inside one classification between the concept, the item, or between the item and the levels. And so here we will consider the semantic relationship that connect different classification resources. So previously we have seen that we can link the scheme, the classification, to the index entries. So the index entries defined in a different data set, or we can link, we can link the concept to the index entries. We can link the classification to the classification family, or the concept scheme to the series. But we can also connect the item to item in a corresponding classification. So for instance, NACE 2.1 to NACE 2 or NACE 2 ISIC. And in that purpose, we use the SKOS mapping relation, and we can apply the SKOS mapping subproperties, the exact match, close match, broad match, and so on. But this is simply properties, a relation, but there are no context. So we are mapping two code item, but that's all. So the alternative is to develop correspondence table. So the correspondence table is a set of mapping between classification items from two statistical classification. So this is similar to the SKOS mapping properties, but in addition, we can provide contextual information such as a description of the mapping, a justification of the mapping cardinalities, nodes. And so this is represented, it's inside another class called the XKOS Concept Association. And in a correspondence table, XKOS correspondence, so you will find a set of concept association, each one with a context about the correspondence. So if you want to get more information about the GSIM, you can consult the concept group or the GSIM statistical classification model, the GSIM user guide, section 3.6 and 3.7, or the SKOS Simple Knowledge Organization System, XKOS, and also the XKOS best practices. And if you want to browse the NACE or the other ESS classification, you can access to SHOVOC. Thank you.